Welcome to the DIY Honda Garage channel. The DTC Diagnostic Trouble Code P0980 relates to the Shift Solenoid Valve C, indicating an open circuit in its functionality. This error suggests a problem in the electrical circuit associated with the valve, preventing the transmission from shifting to specific gears, namely the second and fifth. It is vital to note that this issue cannot stem from mechanical faults within the transmission itself, but is solely electrical. The PCM, Powertrain Control Module, stores this code and does not allow shifting due to the fail-safe mode activated by the code detection. Understanding the roles of the components involved is crucial. The shift solenoid valves are responsible for directing hydraulic fluid within the transmission, allowing shifting between different gears. If this code is active, it impacts the vehicle's performance significantly, leading to suboptimal driving experiences. The Shift Solenoid Valve C is a critical component in the transmission system, responsible for controlling fluid flow needed for gear shifts. The PCM, located typically near the engine or in the underdash area, processes data from various sensors and controls components like the shift solenoid to ensure optimal performance. When the PCM detects an open circuit in the solenoid coil, it registers DTC P0980. This error results in the failure to shift the transmission into the second and fifth gears, activating a fail-safe mechanism. It's essential to understand that this issue does not occur due to mechanical failure, but rather an electrical circuit problem. This understanding underscores the importance of the electrical integrity and connectivity within the transmission system, encompass solenoids and the PCM. Various factors may contribute to the occurrence of DTC P0980. Most commonly, there are electrical circuit issues that disrupt the operation of Shift Solenoid Valve C. Damaged wires, connectors, or terminals can lead to open circuits where normal current flow is interrupted. Additionally, blown fuses can cut power to essential components, preventing proper function and activation of the solenoid. Faulty shift solenoids themselves can also be a primary concern, as deterioration or internal damage leads to malfunctions that trigger DTC codes. Identifying the specific cause is paramount for effective resolution to prevent similar issues in the future. When DTC P0980 is present, the driver may experience significant symptoms that affect vehicle performance. Most notably, the transmission may fail to engage in the second or fifth gears, severely limiting driving capabilities. As a fail-safe mechanism, the vehicle enters a protective mode to prevent further damage, restricting the system's operational capabilities. Consequently, the vehicle may respond sluggishly or not reach optimal speeds, affecting fuel efficiency. This limitation can also cause increased strain on the engine as it tries to compensate for the lack of shifting, potentially leading to further mechanical issues if left unaddressed. Recognizing these symptoms can help in diagnosing and resolving the underlying problem effectively. The first step in troubleshooting DTC P0980 is to turn the vehicle's ignition to the on mode while ensuring all electrical systems are operational. After powering the vehicle, the technician should use the HDS Honda Diagnostic System to clear the DTC. Clearing the code is essential to reset the PCM's memory for subsequent checks. Once cleared, the engine should be started with the brake pedal firmly pressed, shifting to either neutral, N, or drive for at least 1 second. This process allows the system to reinitiate its self-diagnostic routine, and the technician should again check for any pending or confirmed DTCs using the HDS. The goal here is to determine if the fault is persistent or if it was an intermittent issue, which can provide key insights into further troubleshooting pathways. Next, ensuring the vehicle is turned off, lock mode, is crucial before proceeding to check the fuse. The fuse in question is C31, rated at 7.5 amperes, located within the under-dash fuse or relay box. This fuse plays an essential role in providing electrical power to the Shift Solenoid Valve circuit. The technician must inspect the fuse visually for any signs of damage or a blown element. If the fuse is intact and operational, they should proceed to the next step in the troubleshooting process. Conversely, if the fuse has blown, it must be replaced, and if it blows again upon testing, further investigation for a short circuit to ground within the circuit is warranted. In the third step, the technician should jump the SCS line using the HDS, which is a service check socket designed for diagnostics. After waiting for over 1 minute, the next action involves disconnecting the PCM connector A, which typically has 51 pins. With the vehicle set to on mode, voltage measurements should be taken between designated test points at PCM connector A. Test point 1 should be the number 1 pin of the connector, while test point 2 connects to a reliable body ground. This step is critical. If there is battery voltage at this measurement, it indicates that the wiring leading to the IG1VB solenoid line is intact and functional. Should there be no voltage present, it suggests an open circuit in the wiring, necessitating repairs to the wire between the PCM and the C31 fuse. After verifying the wiring integrity, proceed to reconnect the PCM connector A securely. Follow this by disconnecting the Shift Solenoid Valve C, utilizing its 2P connector, which contains pivotal connections for solenoid operation. In this step, the terminals A and B of the solenoid will be bridged using a jumper wire, where terminal A connects to number 1 of the solenoid 2P connector, and terminal B connects to a body ground. This temporary bypass creates a direct pathway for power, allowing the solenoid to be tested effectively. Once the connections are made, turn the vehicle to the on mode and utilize the HDS to clear any DTCs. Starting the engine after this adjustment allows the technician to assess for any new pending or confirmed DTCs. Notably, if DTC P0979 shows up, it points to an issue directly with Solenoid Valve C. Upon checking for DTC P0979, if the code appears, the technician must turn the vehicle to the off lock mode. After ensuring that all jumpers are removed, continuity tests will be performed between specified test points. For this test, measure continuity between the second pin of the solenoid's 2P connector and a reliable body ground. If there is a clear continuity reading, it indicates that the solenoid valve C is likely faulty and needs to be replaced. However, if continuity does not exist, this suggests that the solenoid is functioning correctly. The focus will then shift to the SHC PG wire, requiring verification of its integrity and checking for a secure ground at G101, an essential grounding point for reliable circuit functionality. In the sixth troubleshooting step, the approach involves reiterating the process of jumping the SCS line with the HDS, ensuring a minute-long wait for stabilization. Proceed by disconnecting the PCM connector B, which similarly consists of 51 pins. Subsequently, continuity needs to be checked between specific test points, namely, between the first pin of the Shift Solenoid Valve C's 2P connector and the third pin of PCM connector B. A successful continuity reading signifies that the SHC wire is intact, and the focus should then shift towards replacing the PCM if needed. If continuity fails, it suggests a break in the SHC wire leading to the solenoid, thus requiring repair work to restore functionality. Following successful repairs, it's vital to verify the integrity of the entire system by clearing the DTC using the HDS. After clearing the code, the technician should proceed with a road test under varied driving conditions to ensure the vehicle shifts smoothly without any interruption. This test drive will help confirm whether the issue is resolved and will validate the repairs made. The technician should be on the lookout for any reoccurrence of DTC P0980 or new codes that might emerge during this phase. The driving conditions should closely mimic those that presented the original symptoms for accurate results. Conducting this final verification step is crucial to ensure reliability and functionality of the vehicle before returning it to the customer. To prevent future occurrences of DTC P0980, regular and thorough inspections of the vehicle's wiring and connectors are paramount. Damaged wires can lead to costly repairs if left unnoticed, making routine checks essential for maintaining the electrical integrity of the transmission system. Utilizing high-quality connectors can further safeguard against connection failures that lead to intermittent circuit issues. Technicians should also monitor transmission performance closely, especially during routine maintenance checks, highlighting any unusual shifts or delays that could foretell underlying problems. Educating the vehicle owner on early detection signs is equally crucial, empowering them to seek timely assistance and ensuring that the vehicle remains in good operating condition throughout its lifespan. In conclusion, DTC P0980 indicates an electrical fault related to Shift Solenoid Valve C, affecting transmission performance. The troubleshooting process focuses on identifying issues within the solenoid itself, verifying connections, and ensuring continuity throughout the relevant wiring to the PCM. It's critical to understand that mechanical problems within the transmission are not responsible for this code, guiding the technician's attempts towards purely electrical diagnostics. To prevent future issues, ongoing preventive maintenance is essential, emphasizing wiring inspections and component functionality checks. Keeping open channels of communication with vehicle owners regarding potential signs of problems can ensure timely interventions and promote overall vehicle health. Please like and subscribe to the channel. See you next time.